So now let's see what is circular permutation. So in case of circular permutation, suppose n objects are like placed on a circle, 1 2 similarly till suppose 3 4 so on till n objects are like arranged in a circle. So how many unique arrangements you will get? So you have a formula that n minus 1 factorial ways. So now you must have been having a curiosity how n minus 1 factorial ways. So let's see. So for example, suppose let's compare it side by side with the linear arrangement. A, B and C, like 3 different persons are to be arranged on a linear line. So how many arrangements we will get? A, B, C, then suppose A, C, B, then B, A, C, then B, C, A, then C, A, B, then C, B, A. So total how many ways? Like you can arrange it in 6 ways if you are asked to do it when they are sitting in a linear way. So this is like 3 factorial, okay, which we know the formula also, like we don't have to like manually do always. But let's compare this with the circular permutation case. So what happens in circular permutation? Suppose this A, B and C is sitting in this fashion. So what you will see is that here A, B and C is equal to B, C, A is equal to C, A, B, because they are sitting in, if you see in the clockwise way, this fashion. So A, B, C, and if you start from B, C, A, these are both are same because you are seeing in the clockwise fashion. So here you can see that 3 of these, like A, B and C, from here A, B and C, B, C and A, B, C and A, then C, A and B. So these 3 are like same arrangement. So for, and suppose if you see anti-clockwise direction, like let's see the anti-clockwise direction. So in that case you will see that, so like C, B, A is equal to B, A, C is equal to A, C, B. So again you can see that for 3 different arrangement in the linear, we get only 1 arrangement in the circular permutation. So you can see that here we are having only 2 arrangements, like one in the clockwise sense and one is the anti-clockwise sense. So like for the linear, what we got 3 factorial ways, but in this case we got only 2 ways, which we can write as 2 factorial ways. So like you can see that what happened is, what is happening over here is that n factorial, we are actually dividing it by n, that is n factorial by n, we are getting n minus 1 factorial, so which is 2 factorial. So now if let's derive this, like how let's derive this for better understanding. So what we are doing is that suppose this is A1, the first person, second person, this is the third person. Similarly if you go till this is AN and the second last person is AN minus 1, and suppose this is so on. So what we will do is this, now we will fix one person, like suppose if we fix one person A1, that he has to sit over here only. So now the relative position will not change. So what let's do, let's break this circle from here. So because A1 is fixed, we are fixing A1. So when we fix A1, then what will happen, that from A2, A3 till AN, all will come in a linear sequence. Why? Because we have fixed one, we have fixed the A1, because A1 is fixed. So if you fixed any one person in the circular permutation, then it will convert into a linear permutation. So now you are left with only n minus 1 persons, and we are having n minus 1 places where they will sit. So now applying the linear permutation formula, it will give us n minus 1 factorial. So I hope that you have understood how this n minus 1 factorial comes for the circular permutation, because if you have to fix some person in order to, like in that case only the arrangements will be different. Otherwise if you don't fix it, then it will be like same for multiple cases and you will like not get the result. So like there is a special case if suppose the both the clockwise arrangement and counterclockwise arrangement are same, as is example in the garlands or beads, necklaces, or like garlands. In that case what happen is that both the clockwise as well as anti-clockwise both are same. So here what we will do is that here we will divide this n minus 2 factorial by 2. So this will be the number of ways. So I hope that this special case is also clear. So thank you. So now let's see some simple and direct questions on circular permutation. So in first question you can see that like 5 persons sitting on the circular table. So how many different arrangements can be possible? So you know the formula n minus 1 factorial, which is 5 minus 1 factorial, that is 4 factorial ways. So which will be like 24 ways. So it is very simple and direct question. So let's see one more question. So in this case we are having like a necklace which is having beads of different colors. So total 6 beads are there. So and we are asked that how many total arrangements are possible, like how many permutations are possible. So we have seen that in such questions we actually do n minus 1 factorial divided by 2, because here clockwise and anti-clockwise both are not different, they are same. So that's why now let's see. So 6 minus 1 factorial divided by 2, that is 5 factorial divided by 2. So how much it is? So it is 120 divided by 2, that is 60 ways. So these are like two simple and direct questions based on circular permutation.